Hi there, let me hope you're fine. Mathematical induction as a method of proof. We are going to ensure that you understand about how to go about it. I've provided an example. The best thing a student has to note when dealing with the mathematical induction method of proof, this is a method that has 3 steps. The first step, the student has to note that he has to check whether the equation or the question provided with is respecting this rule, whereby we are saying n should be equal to 1 and proof. Then assume the statement holds for the value n. Then after assuming for the statement holds for the value n, the student has to proceed on by showing that the statement is true for the value n plus 1. Let's check how we can do out this. I've provided an example. Proof that we are having, that is 1 6n n plus 1 2n plus 1 by mathematical induction. So proving this, the solution I've provided here. Solution 1, we have to find out that if n is equals to 1. So what we're going to do, we are going to check, we are going to just simply place where there is 1, where there is n, we substitute it with 1. So here we're going to place 1 1 1. So of course here that is 1 plus 1 2 times 2 times 1 2 plus 1 3. So there is 3 times 2 6, of course, and 6 times a 6 you'll get 1. So we say now we've proved that n is equals to 1. That's step number 1. If I told we could have used 2, the same thing could have happened. Place here 2 2 2, whereby we are going to have here 2 3, here 4 5. So that is 5 times 3 15, and 15 being multiplied by a 12, you still find a good number. That is there is 2 over 6. Of course you get 1. Then from there we are moving to assume it holds for the value of n, and also show it holds for n plus 1. I've combined the second and the third property or condition. So here is our here is our equation and other question, and I've moved on now to simplify further. As you can see, I've now established that 1 over 6 n plus 1, then 2n plus 1, then plus, now of course I told you that we need also to prove that n plus 1. So we are going to do all this, then plus n plus 1, then remember to place the square. Then from there we are having 1 over 6, and when you try now to expand this, it will be now n. We are now placing the n inside the larger bracket and have n as a factor of n plus 1, then 2n plus 1, then plus 6n plus 1 squared. Somebody can ask himself or herself, where is this 6 coming from? Of course, we are having initially this 1 over 6. So this is another, let me call it another property. And here this is also another property. Because we are having this, and for the fact of the LCM, we are going now to place here 6, in that it equates this other side. Or we have, let's say, a balanced situation. Then we move on to have a 6, that is n plus 1, 2n plus 1, then 6n plus 1. Remember, this n plus 1 is squared. Then we are having a 6th n plus 1, and we've now extracted this n plus 1, and remain now, after extracting being multiplied by a 6th, we are now going to remain with this n being a factor over, or being a multiple of 2n plus 1, then closing, we are going to have then plus 6, of course, n plus 1 squared. And now when you try to check this one, what we've done, because we brought this out. Why did we bring out n plus 1? It is because it is common. So you see, when you bring this n plus 1 out from this point, from this larger bracket, it means also because this one is n plus 1 squared, we are going now also to remain here with n plus 1, thus eliminating the square. Then we move on to have a 6 n plus 1, then the bigger brackets 2n squared. Of course, when you multiply this, 2n squared, then plus n, here it is, then plus, of course, we are multiplying 6n, and 6 times 1, we are having 6. Then we move on again to get, we are having 1 over 6 n plus 1, we are still maintaining it, and here we shall now have 2n squared plus n plus 6. The reason being, why are we having this? Where is, somebody can ask himself, where is now this 6n that was here? You know, what we've done, it is just simpler that we are having now a 6n plus 1, 2n squared plus n plus 6. Then we move on to a 6n plus 1, then 2n. Of course, we are now reducing this. Of course, it's a quadratic one, so we are going to have 2n plus 3 and n plus 2. Then from there we are going to have 1 6 n plus 1, then 2n plus 2 plus 1. Of course, we've reduced this one. Then n plus 2, we are going to have n plus 1 plus 1. Here it is. Then we are having 1 over 6 again, n plus 1. And this one, because we've reduced this one, we can also simplify it further to this extent by now factoring out 2, then remaining with n plus 1, and of course plus 1. Then from there we are moving on to get now n plus 1 and plus 1. Of course, n plus 1 being in its bracket. So to that extent, I would like to say that we've tried to prove that the second and the third condition, that is the second condition that demands us to assume that the equation or the phrase equates to n. Then from there, we are trying also to assume that now what of now n plus 1. So if at all you are going to take note of the three conditions, then it will be simpler on your side to check whether when provided to that is a certain situation that demands you to tackle it with a mathematical induction property or kind of approach. So ensure you continue subscribing. Where you've not understood, you can still stop the video and watch again, and you can also still move on a quite stealthily note and check again.